There are many types of functions, and one among of them is called a periodic function. What's so special about this function is that when we have fx plus p, it will definitely give us f of x, which means that p is known as the period of that function. This is very common to trigonometric functions, sine, cos, tan, and some other things, some other trigonometric functions. So in this class, we're going to consider only that of sine and cos. We are dealing with Fourier series. Like I've mentioned earlier in the first video that we want to represent a periodic function using only sine and cos. So let's limit ourselves. Although there's one tutorial questions that I ask you to show me that of tan x. But before we proceed, one thing we need to learn is that both sine and cos, they have a period of 2 pi, while that of tan has a period of pi, which means that the number of cycles completed within actually 2 pi. So let's consider the first tutorial question, the first example. Example 2.1. Let's consider y equals to sine x. The question here is that what is the amplitude and what is the period? If you look at the sine x very well, you notice that sine x moves from 0 to pi, which means that sine 0 is 0, sine pi is 0, then sine 2 pi is what? Is 0. You will notice that it moves between 0 to 2 pi and completes a cycle. So here now we can say that the amplitude of sine x is what? Is 1. Meanwhile, the period is 2 pi. Now let's consider another example again. That's example of y equals to cos x. The question is this: what is the amplitude and what is the period? If you look at this again, another trigonometric function, you will notice that cos x is actually completes a cycle within 0 and 2 pi. That is why you can see that it's highlighted in black color. So which means that if you look at from 0, you will see that cos 0 is what? Is 1. And when you get to pi, cos pi is what? Is minus 1. So if you look at it very well, you now notice that cos x, which is a trigonometric function, completes a cycle within 2 pi. So we can call that one a periodic function of period 2 pi. So let's consider example 2.3. In this example here, we have 5 sine 2x. So the question is this: what is the amplitude and the period of this particular trigonometric function, which we can also refer to as a periodic function? And one thing we can notice from here is that 5 sine 2 pi, as you can see the graph on the screen, it completes a cycle between 0 and pi. You can see now that between 0 and pi, that function is back again to what? To 0, because 5 sine 2 pi, that is 5 sine 180, is indeed what? Is 0. So from here now, you can now see now that the amplitude here is what? Is 5. The amplitude is 5, while the period is what? Is pi. So let's go straight to example 2.1. So let's try to generalize the whole thing now. We are given that that's tutorial question and answer 2.1. That y equals to a sine 2 pi n pi. And we are asked to find the amplitude and the period of this. Definitely we know that the coefficient of that trigonometric function is the amplitude. So here we can know that the amplitude is what? Is a, which is the coefficient of the periodic function. So you can see that the amplitude is what? Is a. Now what about the period? One thing we can learn from the example 1 and 2 is that the case of sine n pi is same thing as what? 2 pi n. So we can actually use the period. We can use 2 pi n to calculate, to obtain the period of any periodic function. Now let's consider this again. We are asked to confirm the function, the following functions, and we are to confirm the amplitude. But don't forget that the amplitude is the coefficient of the trigonometric function. So here you can see now that 3 sine 5x, the amplitude is what? 3. 2 cos 3x, the amplitude is what? 2. Sine x over 2. Don't forget that there is 1 there. So the amplitude is the coefficient of the periodic function, which is what? 1. So we have it like that. So what about the period? One thing we can use about the period is that we can use 2 pi over n to calculate it. Here now, our n is the coefficient of x. Let's consider, for instance, example, the first question, 2i, which is f of x equals to 3 sine 5x. You can see that here, n is what? N is 5. So 2 pi over n, that is 2 pi over 5. The second example, n is what? 3. So we compute the period, we can obtain the period by calculating 2 pi over n, which is 3. So we can see now that this is also true because the period and the amplitude, they're correct. What about this next case, which is sine x over 2? Yeah, we know that the amplitude is 1, but what about the period? Yeah, n is what? N is 1 over 2. Don't forget, n is the coefficient of x. So n is 1 over 2. So by the time you convert 2 pi over 1 over 2, you get 4 pi. Then the next example, that's 4 sine 2x. Yeah, our n is what? Is 2. So when you do it, you can see that your period is what? Our period is what? Is pi. So we have it like that. So we're going to stop here. The question now is that you have to sketch the graph of tan x. You can go online to obtain this graph. But one thing I want you to tell me is that what is the period of tan x? And is it really true that the period of tan x is pi? Please cross-check and let us know. And you also have question 2 and 3, which we're going to do online. Thank you very much.
We share
tutorial questions and answers.
It is all about understanding facts and sharing with others.
Learning continues. We are learning to know, understand, and share with others.
Please subscribe to our channel if you like our videos.